Hi, welcome to this lesson on calculus derivative laws. Let's have a look at question 5. If we are given that y equals x cubed plus 3x squared minus 9x plus 1, then find the values of x for which the first derivative is equal to 2 at that point. Okay, so first of all, I have y equals x cubed plus 3x squared minus 9x plus 1. So if I want dy dx, which is the same thing as saying your derivative of f at x, right? These are all the same notations. Then I can use the sum and difference laws. It's the derivative of x cubed plus the derivative of 3x squared minus the derivative of 9x plus the derivative of 1. So the power law says that'll become 3x squared, and here it'll become plus 6x. Here it'll become minus 9, and the derivative constant is just 0. Okay, so now we've got our derivative function f prime x. It is 3x squared plus 6x minus 9. Now we want to solve this equation when it's equal to 2. So we have a quadratic equation that we need to solve now. So let's bring the 2 across. So we have 3x squared plus 6x. Now minus 9 minus 2 is going to be minus 11 equals 0. So now I have a quadratic equation in the general form equals to 0. I don't know if this will be able to factorize very nicely because 11, the only factors are 1 and 11, and I can't really see them making a combination of 6 with this 3. So what I'm going to do is I'm going to use the quadratic formula. Right, so recall the quadratic formula is x equals minus b plus or minus the square root of the discriminant term, b squared minus 4ac, all over 2a. So it's going to be negative, my b is 6, plus or minus the square root of 6 squared, minus 4 times a, which is 3, times c, which is negative 11, all over 2 times 3, which is a. So let's go ahead and put this into the calculator. So for the first one, so let's just bring it across here. So we have negative 6. I'm going to do plus first. The square root of 6 squared minus 4 times 3 times negative 11, all over 2 times 3, which is 6. So my first one I get is 1.16 to 2 decimal places. Okay, so I'm going to say, therefore, x equals 1.16. All right, so let's just pull that up again. Or if I do my negative now, it's going to be negative 3.16. So what have we actually shown here? There are 2 x points. So when we eventually see what this graph looks like, so at x equals 1.16 and at x equals negative 3.16, the associated y values, which we can check fairly easy by plugging it back into the original expression. So what I'll do is I'll take it as, so we just want a rough estimate idea. So I'm just going to say 1.16, right, cubed, plus 3 times 1.16 squared, plus, not minus. Okay, so let's just go back and correct that. Right? And then I'm going to say minus 9 times 1.16 plus 1. Okay, so negative 3.84, which is somewhere up here, or down here rather. So at 1.16, it is negative 3.84. Okay, and then for negative 3.16, similarly, if you replace that value inside the brackets now with a negative 3.16, then we'll get what value coming out of the function? Let's have a look. Okay, so let's make sure everything's typed out fine. We get 27.84, which is way up here. So that's that point over there, negative 3.16, 27.84. Now, what does this mean for those points? It means that when the curve goes through them, at that point, when we look at the tangent line, the gradient of that tangent line is going to be 2. That's what this interpretation means. Okay, so it's really important that we keep understanding that the first derivative is telling us what is the gradient of the tangent line at that point on the function. All right, so that's how we would do this type of question. I'll see you in the next one.